Hi, my name is Jose Martinez, and first of all I wanted to say thanks to the reviewers for accepting to review this paper, which is, in my opinion, a not very nice task, considering especially how busy the reviewers could be, and that you then receive any direct compensation about that. So thanks, and I really appreciate the time you're going to spend, or you already did, on the paper. And before starting, what I wanna say that sorry about my English. Okay, I really apologize because I think you are gonna get very tired with my English. It's slow and I don't talk in a good way. So sorry about that. So this is a screencast that I just prepared for the reviewers of the paper that talk about the topology rule system that I developed and I presented for the first time in this paper. I developed the software Jaspa, that is a special extension that can run using PostgreSQL or H2 or Oracle as a backend. And we developed the topology rule system over Jaspa. So here you can find the Jaspa site, and you can download a Jaspa project with the topology rule system, and especially you can check too all the documentation that sometimes I talk about the documentation in the paper. So the Jaspa software just took us almost 2 years for developing, and the topology rule system, after that we started to develop after the first version of Jaspa. Then we started to develop the topology rule system that it took me around 9 months, almost 1 year. So we just wrote one paper from presenting the Jaspa software in the journal that you can find too from the references in the paper. And this is the second paper that is just talking about the topology rule system. So you have some workshops here that you can follow if you are interested in Jaspa, and especially I want to show you the online help. So I want to show you the chapter that is talking about the topology rule system. So this is just chapter 6, and you can find all the commands for running the topology, and you can find all the topology rules names, and especially many this is all the topology rules. That's almost 70 topology rules, and you can find like graphical example, one graphical example for each topology rule. So in order to develop Jaspa, I just use a virtual machine. That this virtual machine is not on the website, but if you are interested in, I can upload and you can use it. So I use Eclipse to develop Jaspa, and Jaspa is developed using Java and SQL. So of course it's not the purpose of this paper to present Jaspa, because we already did in another project on all this package. But the new things, and what I think is very interesting, is the topology rule system, because it has unique features compared with any other software. So one of these features is, for example, that the user can design his own topology rule. So I want you to check just this package, that is topology package, and this class, which is rule.java. So in this one, now you can find almost 70 topology rules in Jaspa that are already designed, but you can design any other rule. For example, this rule is called must not intersect. It's gonna take just one layer. So you just have to write this SQL script to design the role, and just take into account that this SQL script has some parameters, like for example, you cannot use the geometric column name. Of course, you don't know the geometric column name that has the table, so you are going to use this parameter for the geometric column name of the first table, or you are going to use this parameter, table 1, then Jaspa is going to change, it's going to translate these parameters. So if a user is interested in designing new roles, I think the user can learn just from this SQL script. And the another interesting Java code is this one, that is toporules.java. So this is the main source, that is the engine that is running this SQL scripts and is taking into account the dirty areas. It means in the layers that the SQL script is going to apply just for the features, for the geometry that has been changed, and the rules are not going to apply over thousands of features, that just is using small transactions and like sending this SQL like partially. So all of this one is this topology rule .java is, I mean, the engine, the main engine of the topology rule system. Of course, we have other packages that they are very related with topology, like Snap, that this is the snapping process, the snapping algorithm between two layers. Or we have to design another Jaspa functions to design some rules. Okay, so I don't want to bother you more with this code, so let's do an example. So I'm gonna open a terminal, and then first of all I'm gonna make a new spatial database. I'm gonna use Postgres for that. And with Postgres I have a lot of database here, but I have a database that is a template of Jaspa. So I'm gonna make a new one. I'm just gonna copy and paste the code. Okay. So this one, for example, I'm gonna put S4. So I'm gonna make a new spatial database from the Jaspa template. And then now I'm gonna import two layers, so the same layers that I talked in the paper, that they are varialin and variapol. So I think these layers, they are here: documents BTA, varialin, variapol SQL. So I'm just gonna import first varialin. So Jaspa has all this command to convert, say, file to SQL, etc. that I don't think is important now, because we are not talking about Jaspa. Really, we are talking about the topology rule system that we develop over Jaspa. And then I'm gonna import variapol. Okay. Before starting, I'm just gonna open pgadmin 3 because I want you to see that Jaspa is installed over database S4. Like is that one. So we have one schema that is called Jaspa, and as you can see, we have 569 functions. All these functions are Jaspa functions, like a store procedures made in Java. Okay, and here we have the like two metadata tables, that is Jaspa, and what I wanted to show you is in the public schema we have the two tables, vAreaLin and vAreaPol, that we are gonna work with. Now we are gonna display using Cosmos like is a GIS desktop that we already developed a plugin that can understand Jaspa database. So first we are gonna show you the two layers. So I'm gonna change, this is the spatial reference system, okay, and then I'm just gonna download. So this is not PostgreSQL, but we didn't change the name of the driver, because this is experimental. So this is not PostgreSQL, and really this is Jaspa, okay. So I'm gonna put S4 and the username and the password, and then we are connect. So we didn't use PostgreSQL for anything. This S4 is just Postgres, okay, Postgres and Jaspa on it. So I'm gonna download both, and this is the same example that I used in the paper. Okay, so as you can see, you have some polygons. This is in blue, and you have vAreaLin that contains lines. So we are going to apply a rule, topology rule, because really we want the geographic model. It's mandatory that the boundaries of the polygons, like, has to cover perfectly the lines, okay, of this two second layer. But not all the lines. It has to cover just the lines that has a specific column name, attribute name, that is component 1D, and it could be bore, okay, this one is gonna be bore 2, okay, or it can be like that one is already has to be covered from polygons of vAreaPol 2, okay, but not that one. So the cartographic model told us that this is center line, it's called eje, and then this line shouldn't participate in the topology rule, okay. So we are gonna start to creating the topology, to add the topology rules, and to validate the model. Then we are gonna make a connection to S4, and then the first command, this is Jaspa topology command, that we are going to create a topology, for example T1, we can use any name, okay, and then second one, we are going to add the layers that we want them to participate in the topology T1. So this is vAreaPol and vAreaLin, okay, and now we are going to apply one rule. We are going to use, we can use many rules. In this case we are going to just apply one rule that is the same rule that we describe in the paper. So this is a rule that is called must be covered by boundary of layer, okay. So this is a rule that we are gonna add in topology T1 using two layers, vAreaLin, vAreaPol, and using a filter. That this is another unique characteristic, unique feature of this topology rule. So we are going to apply just when component 1D like start with P. Okay. And then, for example, we are gonna validate the rule. Okay. First, we are gonna apply this rule without snapping. Okay. By default, this topology rule system doesn't use snapping. So we are gonna validate the rule. Validate rule 1 on T1. So we know this is rule 1 because in a metadata table we have the rules, and the rule is rule 1. Okay. So I'm gonna show you before doing this one. So I have other commands, for example, to show the rules. Okay, sorry. So that one. Okay, show rules on T1. And then it's going to tell me there's a table that it has just one rule. So this is the number of the rule, okay, that I'm using in the validate command. Okay, so now Jaspa is working. So now it's validating the rule over the full layers, already finished. So as you can see, it's really fast. Okay, so it tells us that before it didn't have any error because it was the first time, and after the validation we found 1313 errors. Okay, and these errors, the topology rule system create a new table, new geometry table with all these errors. So we are gonna try to display this table with Cosmo. Okay. So, okay, then I'm gonna connect again, and you can see this is new one. Okay, so Jaspa create this table. Then I'm gonna open, and all of these are errors. Okay. So most of these errors are because the geometries from the two layers are very close, but they don't match exactly. Okay, so I'm gonna go, for example, here, and this is showing me that these lines are not covered by the polygons, the boundary of the polygons. Okay, but if I put the polygons, I can see, yeah, the polygons, the boundary are covering. So I'm gonna make zoom, I'm gonna make zoom, I'm gonna make more zoom, 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 zoom. As you can see, now, like the boundary of the polygon is here, and the area line is here. Okay, so this is error. Okay, so next step, I'm gonna show you, like we are going to apply the same topology rule, but with snapping process. We are going to apply one tolerance to avoid all these errors. Okay, like tiny errors. So to do so, I'm going to change the definition of the layers with this command. So I'm gonna change the layer area line on topology T1. I'm gonna use a snap through. Okay, so I'm gonna use a snap through, and I can use another parameter that is called tolerance. Okay, to say the tolerance that I wanna apply. If not, I think by default it's like 0.001. Okay, so I'm gonna just use the one by default, and I have to say Jaspa that another layer I'm going to apply a snap through. Okay, and now I'm going to validate again the rule. Okay, so it's going to take a little bit more time because first of all it's going to apply it's going to apply a snapping process, and after the snapping process, it's going to apply the topology rule again. Okay, but the snapping process is going to apply just once. Okay, and of course, if we change some features and geometry and we validate again the rule, it's going to just apply just to the features that we already changed. So as you can see, before 1300 and now just 103. Okay, so I'm gonna show you, like now I'm gonna open the attribute table. We just have 100 features with the errors. Okay, and this is the primary key of the VARIA-lin. Okay, so I can link with the VARIA-lin. So then these are really mistakes. Okay, so I'm gonna put this one. So as you can see, it's gonna tell me that this is mistake. Okay, but it's not just because the geometry in this case. In this case, it's because if I put VARIA-lin, okay, this is one mistake. Okay, one error. So if I check this line, this has this VVI that it tells us, according to our geographic model, that this line must divide two polygons. So one polygon here and another polygon here. But this is just one polygon. Everything is one polygon. Okay? Everything is one polygon. So it means, even though it's not a geometric error, like it's kind of semantic error. Okay? And of course it could be errors like the boundary, it doesn't match the geometry, with some meters. Okay? Sorry, as you could hear, the telephone was ringing, so I'm sorry about that. So I was saying that now just 2 SQL scripts was run. Okay, so if we go to the display Cosmo again, so we are gonna check now, and as you can see, it already shows us that we have here one error. Okay, so for finishing, we are going to apply a second rule between these two layers. So the goal of this topology rule system, that is, we can model a complex geographic data models like the proposed by SPY, and another one that we are already using in Spain. So with other software like even ArcGIS, that is the most advanced software with a topology rule system, we couldn't make it because Jaspa has now almost 70 topology rules and ArcGIS just around 30, and we couldn't find many rules in order to model our database. Besides that, with ArcGIS we couldn't develop, customize our own topology rules as we can do with Jaspa. All of these things, plus another features that we already talked in the paper, we think that makes Jaspa like a unique solution for validating complex database model, geographic database model. So the second rule we are going to apply now is a rule that is going to check if all the center line are inside the polygon. So this line and this line are inside the polygons. So that line it has like component 1D that is called eje, and that one that is inside 2 is called echo. So both are like center lines. That center lines in Spanish is called eje. So we are gonna discriminate these two lines with the attribute name that start with E. Okay. So then the user should go to the help, to the topology rules help, and then check if this topology rule is already made in Jaspa. So we are gonna check in topology rules chapter 6. We are gonna check like line polygon rules. Okay, so we're gonna go here, and then what we want is like this rule, like must be covered, line features must be covered, but second layer that is a polygon layer. So the topology rule is gonna be this name. Okay, so I'm gonna write a sentence, and the sentence will be something like that. Look at rule, this is the rule. Okay, we already saw, and the expression instead with that one, like the first rule, would be this one. Okay, this is the one we are looking for. Okay, sorry, I made a mistake. Must be covered by layer. Okay, now so the topology rule is already add, and then I'm gonna change. I'm gonna check that one. Okay, because this is the second one. Okay, sorry, another mistake. I'm gonna check the show rules to tell me. Okay, because I think maybe because it's gonna be number 3. Because when we try to add the rule, we made a mistake. Okay, so I think no, it's 6. Number 6. Okay, so that one is number 6. So I'm gonna validate rule 6. Okay, so it's already validating the rule, but this tells me that there are 46 errors. Okay, so I'm gonna go Cosmo, and then I'm gonna open. Now I have see the 6th rule in topology 1. So I'm gonna open that one. Okay, and it's gonna tell me all the errors that I have. Okay, for example, that one. See, that one it doesn't have any polygons. Okay, or for example, we are gonna check this one, that we have another error here. Okay, so you can see this is error. Of course, this is not center line. Okay, so this is another error that is telling us that maybe I'm gonna check the line. Look, I'm gonna check the line here, and this eje, it shouldn't be eje. Okay, it shouldn't be eje. Okay, so we can find many mistakes in an easy way with these topology rules. So thanks a lot. This is everything I want you to see at this moment. I really apologize about my English. I'm so sorry about that. And if you have any question about applying or using more rules, just please tell me, and I can develop more examples. So I want you to consider this paper, because it was a really very hard work during almost 3 years until we were able to develop this system. And we think that we already are using specifically features, specifically characteristics that other products don't have, and at this moment we couldn't validate, we couldn't model our geographic models with the current software, even open source software or private software. This is the first time too that like a special database backend are incorporating this kind of rules too. So thank you a lot for your time.